Lesson 5-5. Use inequalities in a triangle. By the end of today's lesson, we will successfully be able to find possible side lengths of a triangle. Example 1. Mark the largest angle, longest side, smallest angle, and the shortest side of the triangle shown below. And what do you notice? So I'm going to first mark the largest angle, and then the longest side, and then the smallest angle, and the shortest side. And I noticed that the longest side and the largest angle are opposite of each other. And the shortest side and the smallest angle are also opposite of each other. Example 2. List the sides of triangle PQR in order from shortest to longest. So I noticed that 45 degrees is my smallest angle, so QR has to be the shortest side. And 55 is the next largest, so QP will be the next longest side, and 80 degrees is the largest angle, therefore PR is the longest side. Theorem 5.10. If one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. So if the longer side here, AB, is longer than BC, then the angle opposite AB, which is angle C, is larger than the angle opposite BC, which is angle A. So therefore, AB is greater than BC, so measure angle C is greater than measure angle A. Theorem 5.11. If one angle of a triangle is larger than another angle, so angle A here, 50 degrees, is larger than angle 30 degrees, which is angle C here, then the side opposite the larger angle, which is BC, is going to be, again, larger than the side opposite of the smaller angle. So when angle A is greater than angle C, then BC, segment BC, is greater than segment AB. Example 3. A long-tailed boat leaves a dock and travels 2,500 feet to a cave, and then 5,000 feet to a beach, and then 6,000 feet back to the dock, as shown below. One of the angles in the path is about 55 degrees and the other is 24 degrees. What is the angle measure of the path made at the cave? By observing this picture here, I can tell that 6,000 feet is the longest or the largest of all sides. So this makes the angle here the largest as well. So I can write the cave is opposite the largest side. So by theorem 5.10, the cave is the largest one. or has the largest angle. So the total degree, by the triangle sum theorem, the total sum is 180 degrees, and we subtract the two smaller angles, 55 degrees and 24 degrees, we get 101 degrees. Theorem 5.12, the triangle inequality theorem, states that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So that creates three possibilities. So the first one could be AB plus BC greater than AC. And the second possibility could be AC plus BC greater than AB. And the third possibility could be AB plus AC greater than BC. Now let's take a look at example 4, and this will illustrate how to apply the triangle inequality theorem. A triangle has one side of length 14 and another of length 10. Describe the possible lengths of the third side. So I'm just going to draw a random triangle here. A, B, C. So I can have 14 plus 10 greater than x, or x plus 10 greater than 14, or x plus 14 greater than 10. And this would give me 24 greater than x, and x greater than 4. And this one would give me x greater than negative 4, which doesn't make sense, so we ignore it. There, and to switch this around, or to combine these two inequalities, we can switch x greater than 4 around so that x is between 4 and 24. These are the possibilities. So example 5 is the exact same thing. A triangle has one side of 23 meters and another of 17 meters. Describe the possible lengths. So I can do 23 plus 17 greater than x. And then I can have 17 plus x greater than 23, or x plus 23 greater than 17, but this one doesn't make sense, so we ignore it. And get 40 greater than x and x greater than 6. And to combine these two inequalities, we get x is between 6 and 40. And we'll continue the lesson in class.